Hello all hydraulic engineers, welcome back to the lab section of CE 3300. Today we'll discuss about the third experiment that is titled the hydraulic jump. In this experiment we'll try to create a hydraulic jump in the open channel flume and calculate the flow rate through the flume. We'll also calculate the energy loss across the jump and the variation of specific energy along the flume. A major part of the job of a civil engineer working in the field of hydraulics is designing against erosion from the flow of water. When we try to control the flow of water, it often leads to the potential of having fast moving erosive conditions. Like when we make releases from a reservoir behind a dam into a spillway, the water will come down at very high velocities. This supercritical flow can cause erosion and eventually lead to failure of the structure. So most hydraulic structures will be equipped with some form of energy dissipators on the downstream end to reduce the velocity of flow and protect against erosion. There are many types of hydraulic energy dissipators, but for large structures like spillway, the most common type we rely is the formation of a hydraulic jump. So the hydraulic jump is the abrupt rise that occurs in the water surface when the water at high velocity discharges into a zone of lower velocity. Here you can see the diagram in the reservoir where a hydraulic jump is formed. Another common example of a hydraulic jump is the roughly circular stationary wave that forms around the central stream of water in the sink. The jump is at the transition between the point where the circle appears still and where the turbulence is visible. The water depths on either side of the hydraulic jump are called the conjugate depths. The momentum is conserved across the conjugate depths for a given discharge. At the upstream of the hydraulic jump, supercritical flow occurs where the Froude number is greater than 1, and at the downstream, subcritical flow occurs where the Froude number is less than 1. Froude number can be defined as the ratio between the mean flow velocity to the wave celerity. It is given by the formula v by root over of gy, where v is the velocity, g is the acceleration due to gravity, y is the depth of the flow. Flow is said to be critical when Froude number is 1, and the depth of the flow at which critical flow is occurring is given by the formula q square by w square g to the power 1 by 3, where q is the discharge rate, w is the width of the flume, and g is the acceleration due to gravity. Energy loss across the jump can be calculated by the formula del E equals to y1 plus v1 square by 2g minus y2 minus v2 square by 2g. And finally, the relationship between the conjugate depths y1 and y2 is given by the equation y2 equals to y1 by 2 multiplied by root over of 1 plus 8 fr square minus 1. This is the setup of the flume. If you mark closely, the portion which is denoted Hj is where the hydraulic jump is occurring. Y1 is where supercritical flow is occurring and Y2 is the region from where subcritical flow occurs. The equipments needed to conduct this experiment consist of the flume with the head tank and the tail tank, the weighing bucket, and the gate controlling the entry of flow to the weighing bucket, the display monitor which shows the weight of the weighing bucket, a measuring tape to calculate the length and depth of the flow, and a controller for the tailgate to create the hydraulic jump. To start the experiment, we turn on pump 2. This is the pump 2. The water is extracted from the sump using the pump and goes through this pipe to the head tank. This is the head tank. The water comes to the head tank, and from the head tank it goes to the flume. The water continues to flow from the head tank through the flume. This is the control for the gate in the head tank, and the flow continues into the tail tank. This is the tail tank, and from there it continues through this channel towards the weighing bucket. To control the flow into the weighing bucket, we'll use the gate which we had used in the last experiment. We open the gate. Now the water is flowing into the weighing bucket. Then we'll close the valve in the weighing bucket and we'll take the reading from the value displayed on this monitor. After the flow rate is calculated using weighing bucket, we'll try to create a hydraulic jump controlling the tailgate. We will wait till the hydraulic jump is stable. In this experiment, we observed the characteristics of the hydraulic jump using two flow rates. So after taking measurement for the first hydraulic jump and the flow rate, we'll create a hydraulic jump for the second flow rate. Here you can observe the hydraulic jump is getting formed at a different location compared to the earlier flow rate. After the hydraulic jump is stable, we'll take the measurements of L1, L2, LSJ and Y0, Y1, Y2, Y3 using rulers and tapes. In the end, we'll note the values in our observation table. After the experiment is completed, we'll have the following measurements. These measurements are shown in the table. Feel free to pause the video if you want to note down. The sample calculations shown here are for demonstration purpose only. Students are required to use the data collected by them or provided to them. Feel free to pause and note the calculations. The format of the lab report is shown here and the report is due by 9th April. If you have any questions, you can mail me. Thank you for your time.